Analyzing a graph. Sometimes you will be given a graph and be asked to describe a situation that would relate to that graph. For example, look at the graph below. So here, we're told the x-axis is time and the y-axis is distance, and we have this graph with those variables. So Jack is going to school, and he walks and takes 2 buses. So describe his trip to school using the graph. So we want to really look at each piece of this graph, and you can see almost like this graph is split into 1, 2, 3, 4, 5 different pieces based on the turns or the stops and goes that are happening with the distance and time. It's not just one continuous line. We have to describe each piece. So we can label each piece 1 to 5, and we can describe that first. If Jack is going to school, Jack is going to walk to the bus stop, right? That's taking care of this first part where his distance is increasing slowly over time. Then the second part, it looks like his distance is not moving over a certain amount of time, and that could be because, number 2, he waits for the bus. He's not moving his distance. He's just standing there at the bus stop. Then the next part of the graph, his distance increases very quickly over a short amount of time, so that must be he's on the first bus. Then his distance doesn't move again, so he must be waiting. He must have gotten off the first bus, and now he's just standing somewhere else waiting for the second bus. That's this 4th piece. And then finally, his distance is increasing again continuously, so he must be taking that bus directly to school without any more stops. So we looked and we've described each of the pieces based on looking at distance over time and how the pieces are relating to the scenario that we're given. So now we can answer questions and analyze the graph further, and we can ask, did he have a longer wait for the first bus or the second bus, and was the first or second bus a longer trip? Well, to answer, did he have a longer wait for the first bus or the second bus, let's look at the 2 parts of the graph where he's waiting, where his distance does not move, is the part from 2, the part of the graph from 2 and 4. Now look, the first part is longer line along the x-axis than the second part. So he must be waiting longer for the first bus compared to the second bus. And then when looking at, was the first or second bus a longer trip, we would want to say again, looking at the time, look at the distance compared to the time. If we have the first bus is 3 on the graph and the second bus is 5. So the first must be a longer trip because it went further on the y-axis than the second bus. So the distance was a lot longer than that second bus's distance. Here it's almost like a longer line than the second bus's line for the distance. Let's look at another graph. So this graph relates to studying for a test and actual test scores. So we want to match the scenario with the point on the graph. So we have 4 different scenarios, and then we can make up a 5th scenario, or our own scenario for the 5th point that's left over. So let's see. We have the first scenario is that Joanna didn't study but did fine on her test. So look at the graph. The x-axis is our test score, and the y-axis is our study time. So if Joanna didn't study, that means that she is not going to have a high y value because she would have very low study time, if no study time at all. But she did fine on her test, so that means she's going to have a greater test score. So that could match with point E. So point E is low on the y-axis but high on the x-axis, so that can represent the first scenario. Then we have William studied a long time but did poorly on his test. So now the study time is going to be much higher. So the point will be high on the y-axis, but he got a low score because he did poorly on his test, so he'll be low on the x-axis. So that could match up with point A. Then we have Alfredo studied some and passed the test. So maybe Alfredo has a y value, a study time kind of somewhere in the middle, not very low but not very high, because he said he studied some, so maybe an average or a middle amount for a y value. And then he passed the test, so he didn't do poorly, but he didn't do very good, so he's right in the middle. So that matches up with point C. Finally, we have that Ingrid studied hard and did well on the test. So if she studied hard, that means she's going to have a high study time, so a high y value. And she did well on the test, so she's going to have a high x value. So that can match up with point D. Let's check our work. So we have E, A, C, D. So our last point we want to come up with a scenario for is for point B. So again, think of where we are on the coordinate plane. Our study time is very low. We have a low y value. And our test score isn't that high as well. We have a very low x value. So if our study time is low, we can say that maybe Mary or Bob or whoever didn't study a lot, had very little study time, and therefore did poorly on the test. It's almost the opposite of A. We can say that they studied a very short amount of time or didn't study at all, but did poorly on the test. It's almost combining A and E. 1 and 2 is creating the scenario for B, where the person didn't study and then did poorly on the test. So that can fit that point. Again, it's all about looking at your axis, what variables are we comparing, and then looking and comparing where our actual coordinates are on that graph and interpreting it based on the given scenario. And this, of course, will be different for every given graph and scenario, so you really have to be careful and interpret as best you can with and work with what you have.